Chapter 1. Introduction to Physics. Let's strip it down to the basics, this is the best way to face it. A complicated subject, I'll teach you how to ace it. First part, gotta get your units right. It changes what you're measuring, feet or the speed of light. But are your units right in your problem solving? They're algebraic quantities that keep evolving. And your sig figs round to the right digits. Don't want Weber sign telling you have to fix it. Now let's switch it to trigonometry. SOHCAHTOA is really all you'll ever need. Got the right angle and the hypotenuse, and the opposite and the adjacent too. I'm not in the tracing mood, not trying to be rude. Directionless quantities are called scalars, dude. If you wanna say which direction that's going in, it's called a vector. Give it a little spin. This chapter's a little thin, but it's not over yet. It's more with vectors, which I hope you get. Resultant vectors, add them head to tail. Total displacement, you really cannot fail. X and Y components that we find with trig, or use Pythagorean, yeah, we do it big. Big Al is next, dropping all these forces. Later working power, counting all these sources.
Big Al here on forces, gonna give you a start. It's really not that hard, teach it part by part. There's no need to panic, it's just a part of physics. Simple as B. Brown's class, I'll show you the basics. Now Sir Isaac Newton, creating 3 laws of motion. He inspired physicists, he gave us crazy notions. Newton was determined, he never stopped to know. Let us take a look, now let's give it a go. Newton's first law concerns the net forces and inertia. Now you just hold your horses. When you got balance forces, object movement doesn't change. It has constant motion, it remains the same. Now Newton's second law shows direct relation. More force or mass equals greater acceleration. F equals ma, that is the equation. A universal law that applies to every nation. It is just common sense, forces always come in pairs. It really isn't difficult, so don't go pull your hair. Newton's third law states for every action there is an equal and opposite reaction. I guess I'm almost done, only one more thing. I'm gonna pass this song on to Sahib Singh.
Projectile motion, kinematics, X and Y, gonna break it down and tell you the reason why. Measure displacement, how far does it go? We need acceleration and a little more info. With velocity and time, you can't mess with these rhymes. To calculate the speed and see what's on my mind. Once we got the basics, I'll show you the equations like 1/2 AT squared. You best be prepared. Vectors, split the X and Y's just to see how long it would fly. X speed is constant, no forces applied. We ignore resistance, wave it bye-bye. Now the Y, it's a bit more complicated. G for gravity, it is abbreviated. Don't forget the theta, for it is a crime to calculate distance without it on your mind. Now we got everything, well, mostly the basics. Quran is next, he'll put you in your places.
We here for information, we here to get an A. Work is my motivation, it's what we calculate. We need potential kinetic for total energy. Get W and C. This is physics age, we're in a different sector, we're in a different race. Constant force is a vector, displacement straight. Work is force times S and power's the rate. KE 1/2 mv squared, PE is mgh. Work, energy, and power, study after hours, the test is ours. We deserve some little chocolates and some flowers. Calculate the power, which we devour. At the top of a tower, PE graph is ours. Get the height and mass, multiply by 9.8, we can handle that. We could pass a class, we won't finish last. Don't forget the concepts, we could bring it back. Gotta read the book, check your email now. I guarantee there's a new one from Mr. Brian Brown. Kinetic energy's motion, PE is height off the ground. You gotta show your devotion to get your grade to rebound. I know you like how that sounds, just get the Weber sign down. The force is not conservative, incorporating it now. Now the energy's found, we will never go down. As long as Derek on beats is always around.